All right, welcome everyone. Hopefully you're here to talk AI. And I have to say, I'm happy to see a full house. I think last year I had less than 50% attendance at my reInvent talk, so this is awesome. Great to see everyone here. So I'm Joe Spizak. I manage our partners globally for AI/ML. If anyone caught the news this morning, we launched our ML competency, so I think some of our partners are in the crowd, so congratulations again. Great to have you on board. I'm going to be joined by Jose Noriega, who's our AI/ML partner development manager. He works a lot with our technology partners specifically, so our ISVs. And then we also have others that work with our SIs. So 30 seconds on me. So currently leading our partnerships. Previous to that, I was leading a product team in Amazon for deep learning. Previous to that, I was at Intel trying to get them to understand what machine learning was. And I think I was successful because now it's all over. They bought Nirvana and have whole business units. So they're very excited and very invested. So great for them. So thank you again. Agenda-wise, we actually have a pretty wide-ranging talk here. So we'll talk about market opportunity. Everyone loves to talk dollars and cents. I'll jump into kind of some definitions, why now as well. So there's a lot happening right now, cloud computing being a big driver, certainly of AI and machine learning. This was a 200-level talk, so I have a bit of basics. So who's a deep learner in the room, by the way? Anyone using deep learning, applying it today? A few hands, hesitant hand, 1, 2, 3. Okay. Who's excited about deep learning? Like okay, there's a few excited. Okay, if you're not excited, you shouldn't be here. No, it's exciting. There you go, all right. So I personally got excited about this back when I started using Caffe when it was first open sourced. I think that was 5 years ago, 6 years ago. And I've been kind of hooked ever since. So we're gonna cover a lot of ground here. We'll cover the data science and machine learning workflow. I think data science has largely been considered separate from machine learning, but we're seeing workflows converge. We'll talk about that. Who's running ML and AI on AWS? So we have some great case studies from our customers. And then I'm going to hand it over to Jose, who's going to talk about how to partner with AWS. So obviously the competency is kind of step one, but that's only really a small piece really to the puzzle of working with us. And then some call to action. So first of all, who knows who this gentleman is? All right, Andrew Ng. So I had the privilege of working with Andrew when I was at Intel, when he was at Baidu as chief scientist there. And he has this catchphrase, if no one's caught this yet, called AI is the new electricity. And I think while it's very catchy and it's a great marketing phrase, the reality is more like this. This is the McKinsey chart that shows the heat map of where we're seeing AI and machine learning get adopted. And the darker the color, the more adoption that we're seeing. And I think it's key to point out here that it's not so much the darkness in the color, but it's more of the breadth of what we're seeing. You can see it applied in financial services all the way through to things like tourism and a number of other segments. So AI and machine learning is really disrupting. It's permeating a number of segments. It's not really just for the Amazons of the world anymore. It's for everyone. And I think that's really what Amazon AI and AWS is really trying to do, is to democratize it and bring it to everyone. A couple of stats here, 46 billion, so everyone can talk lots of numbers and big numbers, but that is a big number. So it's growing, I think, close to 50 or 60% CAGR, 54.4%, I think, if I remember correctly, by 2020. Another stat here, we have over 3,000 startups, just checking angel lists, that are quote-unquote AI startups that are applying machine learning in a number of solutions. So it's a really healthy ecosystem. It's growing fast. And we're excited that AWS is going to be the platform that a lot of this is going to happen on. Okay, so I'm going to jump into a little bit of definitions and kind of some of the more basics. And I'll also talk open source, which is near and dear to my heart. So I think there's a lot of discussion around AI and ML and DL, and I think they're kind of used interchangeably. I think that's really not the case. So I kind of put together this slide just to kind of give everyone a level set of definitions. And AI, or artificial intelligence, is really the umbrella term. It's really to sense, learn, reason, act, and adapt to the real world without explicit programming. And you can really, the analog is us, right? As humans, we don't, we're not explicitly programmed. I learn how to walk up these stairs. I learn how to eat an apple, by being able to sense and reason about my environment. Now, in order to achieve AI or really build these intelligent applications, there's a number of different ways. I think if anyone's read Pedro Domingo's book, The Master Algorithm, it's a great book, by the way, if anyone has a chance to read it. It talks about all the 5 tribes of machine learning. There's all the way back to the symbolic approaches, where it's really rule-based. So you can consider it almost like an endless if-then statement in some respects. And then, of course, there's all of the number of different algorithms like decision trees, deep learning, with neural networks. And these are all really these are all algorithms or classes of algorithms that learn from data. And there can be supervised, meaning that you can have a set of XY pairs. I have known ground truth that I'm training my algorithm with, and I could have unsupervised, which means I don't have any ground truth, and I'm just learning and I'm trying to find patterns within the data. And of course, what everyone loves to talk about these days is deep learning. And deep learning is really a subfield of machine learning, and one kind of class of algorithms that has a number of really cool applications that we'll talk about. And I think because of that sensorial, because of that, the fact that it's hitting image classification, it's hitting speech, it's Alexa, it's kind of around us, every day, and it's really engaging. I think people have gravitated towards deep learning, and it's become kind of, I wouldn't say a household term, but people have certainly raised the awareness of deep learning over the last few years. So why now? I think, coming from Amazon, I can tell you compute certainly had a lot to do with it. Our friends at NVIDIA with their GPUs certainly had a lot to do with it. I think if anyone followed the ImageNet competition back to 2012 and they started to see some of the initial, AlexNet, some of the initial neural networks that were trained for the ImageNet competition, that was using GPUs. So parallel computing became really, really important. And you started to see this HPC, this high performance computing, start to bleed into deep learning because they're very similar. They're very compute intensive, they're highly parallel, they're trying to solve kind of similar large scale problems. And then bigger data also is key here. But not really for the reason that I think a lot of people think. They think data is everywhere, data is plentiful. But one of our competency partners that launched with us, Crowdflower, solves what I call the dirty little secret of deep learning. And that's the fact that everything today is very supervised. It's supervised learning. You have to have a lot of training data that's actually annotated, meaning it's labeled. I actually have a ground truth that's been maybe meticulously labeled and edited by someone physically. I've done this myself. We have a lot of services at Amazon. I've been lured with beer and pizza and sat there on Mechanical Turk and labeled sentiment in ads on Amazon. So it's really painstaking, but that really is the impetus and really the foundation of a lot of the really amazing applications you see today, and why you get great recommendations, why you get fantastic NLP. And then lastly, the advanced learning algorithms. I think we've seen a lot of these algorithms that maybe are coming from the 60s or 70s, or if you count reinforcement learning in the 80s and 90s. But there's now enough compute and enough expertise, I would say, to take advantage of them. And over the last, I would say, especially the last 5 or 6 years, there's been really big leaps forward in a lot of these algorithms. So applying reinforcement learning, applying computer vision using convolutional neural networks, and so on. So of course, we all gravitate towards these superhuman benchmarks. We love to talk about, the ImageNet competition, and when the Stanford folks took the ImageNet set of images, and they actually went through them and viewed them and labeled them or tagged them themselves and tried to figure out what human level accuracy would be. I think it ended up being like 95%, if I remember correctly. It's actually labeled somewhere here. And we started to see the CNNs, the convolutional neural networks, actually outperform humans. People got really excited and they got worried, of course. And that's, when you have these kind of narrow problems, you can drive some of these algorithms to really great performance. As you can see over the years, some of the algorithms have driven down into the high 90s or in the 90s for accuracy. of course, chess. If anyone's paying attention to the AlphaGo Zero reinforcement learning work that Google's been doing, a lot of these new algorithms, they're getting a lot of press, but the really cool thing is that they're actually being applied now. So all the things that I saw at Berkeley and Stanford 5 years ago are actually starting to really make it into large-scale production. And the really key thing here is that we're seeing this applied kind of enterprise-wide. So part of my team at Amazon, we track a number of use cases. So we have myself, I'm being a horizontal technology, I would say, for AI/ML. We have a number of vertical teams. So whether it's media and entertainment, whether it's health and life sciences, financial services, et cetera, they're starting to see ML permeate in all of those verticals, and they're starting to track all those use cases. So I kind of cherry-picked a few here. Media being near and dear to my, Media being near and dear to my heart here. You can see some of the things that it's being applied to. So copyright infringement is a great one. It's really, really human intensive to have people constantly looking through content to make sure someone's not infringing on your copyrights. You can see in healthcare life sciences, there's a number of different applications. Drug discovery right now is very hot. All the way through to customer experience. I think we've all started, whether we like it or not, or whether we know it or not, we're engaging with conversational interfaces. Those are everywhere. No matter whether we like it or not, they're there. In some cases, they actually provide a really nice experience and frankly a lot faster than having to call Comcast or whatever company you're dealing with. So the point is there's basically an unending number of use cases. We're tracking hundreds of them, my team is, and we're working with partners to go in and build solutions and solve those different use cases or solve those problems. So it's very exciting. There's just no end to the work that I have to do, so I have job security, which is cool. Cool, so I'm gonna jump into a few of the deep learning basics to kind of give everyone a level set here. So don't get scared by the equation or the math, but this is what we call a perceptron. You can also call it an affine layer because it's fully connected. You can also call it a logistic unit. But this is basically the fundamental building block of a neural network. And you can see at the bottom here, bottom right, there's a little bit deeper of a network with more neurons. And you can see here's the input layer, which is basically where your data comes. Your X's, you're essentially flatten your data ingested into here. With supervised learning, you typically have a Y pair. So this actually will be accompanied by a Y. So basically an image and a result. So this is a cat, there's an image of a cat, and there's a tag that says that's an image of a cat. And then the Y is, of course, the output, and there'll be a Y hat, which is the prediction. And without going into what the chain rule is or what backpropagation is, essentially you're going to get an error by ingesting data into the front of this network, into the input layer of this network. You'll provide some calculation and a nonlinear function, simply multiplying by these weights, adding them up. There's a bias term, and then you have an output. And then you basically compare that output, and you have a loss. And then if you do that a bunch of times, you call that a cost function. And that outputs a prediction over time. You'll converge, basically. Now, this is a very simple perceptron, but things can get more complex. And the real power of a deep neural network is its ability to do deep representations. And you can see once you start to stack these up, and I have another slide, I think 2 slides, it really kind of exemplifies where we are in the state of the art. But you can see that as you propagate through the network, you start to get higher and higher level features. So in other words, the network is starting to learn deeper features. You may start out in the case of images, because it's a very easy way to kind of convey the concept. You start to learn about the edges that are basically within these images. That's what the early layers of the network start to learn. Once you start getting into the middle layers and then the latter layers, they start to actually learn real features like eyes and ears all the way to full faces. And this can be applied to really anything, whether it's natural language, whether it's images, whether it's audio. It's really kind of an interesting way that we've kind of flipped this whole thing on its head. In the past, you would actually define these features ahead of time. Now you're actually learning them through the algorithm. So that's really the power of deep learning. Of course, there is a drawback to deep learning. It requires a lot of data. So how are a lot of these algorithms implemented? And this is where we get into open source. And this is where you'll start to see me get excited because I love open source and I love to work in this ecosystem, and especially early on when I was working on Cafe. So really today, I guess maybe other than Theano, because that project is largely dead today, but there's still a very vibrant ecosystem of open source. So whether it's TensorFlow, whether it's the Microsoft CNTK, the Cognitive Neural Network Toolkit, Apache MXNet, PyTorch, these are essentially ways for you to script and define a neural network and then train it. And it's gotten really to the point where it's actually very easy to do deep learning. And I'll show you just how easy it is. I actually have some code in a couple slides. But it's gotten to the point where if you can write basic Python, you can train a neural network, and you can train one at really large scale pretty easily. So it's exciting. And this was not the case 5 years ago or 6 years ago when I saw people just struggle with basics. So key things about deep learning frameworks, like why are there so many? Well, I think there's a bunch of different reasons why people choose different frameworks. I think ecosystem certainly is a big piece of that. Are there other developers using it? Is there code that I can reuse? Are there contrib packages? Is it a research versus production question? If I'm doing research, for example, the FAIR team at Facebook is using PyTorch, and they use that because you can actually basically run by define, or define by run in this case, and you can literally start to script a network and run it, and it actually defines and runs the computational graph as you're coding. And that's great for research because you can actually iterate really, really fast. In some of these other frameworks, like maybe TensorFlow or Cafe2, you actually symbolically define your graph, and then you go and execute it and compute it. And so it's very good for production because you can then go and very concretely go define what you're doing, train it, deploy it in production, but it's not great for fast iterations. So we see kind of that dichotomy between research and production, and things are merging as we speak. The worlds are colliding, and these frameworks are starting to kind of converge on features and actually even interoperate, if anyone's familiar with the Onyx project that we're now part of with Facebook and Microsoft. It's the Open Neural Network Exchange. So we see these worlds colliding. I think it's going to be an interesting few years here. There's also a few other things to consider. So mobile support, one of the bigger trends in deep learning is to be able to deploy these models on the edge. We have a partner, for example, 2Sense in New York, and they deploy models basically in your iPhone or in your Android phone to detect who you are. They'll basically take the sensors, the sensor outputs, they'll train it locally, and really get a biometric feel for who you are and be able to, you can unlock your phone just by how you handle the phone versus maybe your fingerprint reader or even your face, which can actually be hacked as well these days, I think we've seen. So there's mobile support, I think, is becoming more and more important. Language bindings. As much as we talk about Python, R is still very popular, so is Scala. We talk about programming style, imperative versus declarative. Scalability, so what is my compute and memory footprint? Some of the frameworks are really great for mobile devices. You can deploy them in very small footprints. I can drop them onto a Raspberry Pi. We actually built a little wine detector or wine recognizer, so on a Raspberry Pi, so you can run that over your wine collection if you want. It'll tell you what wine bottles you have. And that runs on a Raspberry Pi. That's a deep neural network. That's a state-of-the-art deep neural network. And then lastly, I think performance. And this is really key, especially when you get into these large data situations and these really large networks where I need to maybe run over multiple GPUs or multiple CPUs or multiple systems of GPUs or CPUs. So scalability actually becomes very important. And what the power of the framework actually these days, and is really that it's gotten simple. So this is actually the MXNet implementation of Keras. So is anyone familiar with Keras? Anyone use Keras? Quite a few people. So Keras is basically an abstracted interface. People will call it a framework, but essentially it's a simplified interface to TensorFlow, now native, was for Theano. And there's also support for CNTK, Microsoft, as well as MXNet. And literally with a couple of lines of code, so I set basically my number of GPUs, I create a list, and I have a 2-line for statement. There, I'm distributing over 4 GPUs now. that's it. I mean, how easy does it get? It's crazy. Like, to do this in the past, this would be hundreds of lines of code, probably a lot of trial and error. Now you add a few lines of code to your project, and basically it's done, and you're distributing over, and you're getting tens of teraflops, which is amazing. So that's really the power of the framework, and that's how far we've come just in a few years. And I guess the reason is why did we go this far? Because I think starting out in LeanNet here, which is a very simple network that originally was developed to allow you to read the checks that you put in your ATM. So when you deposit your checks in the ATM to do basically digit recognition, Jan LeCun developed that when he was at Bell Labs, and that was kind of the state of the art at the time. It was really hard to train because compute was actually kind of scarce. Now we got to the point where, this is 2015, so this isn't even really state of the art. You can't even see the layers of this network in the residual net that came out of the Microsoft research team. And that was state of the art, and that won the ImageNet competition in end of 2015. So the networks are getting deeper and deeper. They're getting more and more complex. Compute's getting, it's kind of insatiable at this point how much compute is required. And really, from a net perspective, it's great to talk about compute. It's great to talk about these deep neural networks. But what is the result, and why do I really need this? And I think the key here is when, for example, I started working with that Microsoft team when I was at Intel. They were talking about 30 days or even longer to train a network. And if you can imagine running something for 30 days or even 45 days and wondering, are you going to get a result or not? That's a long time. That's a long time. You're wasting compute resources. You're wasting a lot of expensive engineers. And I think to really get to iterative research, you have to get to the point where it's a few hours so that I know how accurate my network is, how well am I performing. If I'm having to wait a month or even longer, or 2 months in some cases, for these really large data sets and networks, it becomes kind of the point where maybe this isn't something that is a tractable problem, or maybe I need to figure out another way to go about it. And I think that's what we've seen with the latest hardware, is we've turned some of these problems from, you can see here at 15 days for some of these neural machine translation problems, or longer, down to 6 hours. And that's basically a single P3 now Volta. Now you can distribute that over the full 8 that we have, and you can probably get that down in under an hour probably. So you're talking about really amazing problems, really large networks, and you're training those in a matter of hours now, where, a few years ago it was months. So that's power. That's power for research. That's really powerful for the state of the art and pushing it. And that's why you see services from Amazon, services from Microsoft, and Facebook and others start to just come out at blistering pace because the hardware is advanced, cloud is advanced. Okay, so I'm going to step back and talk about the development workflow a bit. And I'm going to preface all of this by saying, if you don't have a problem in mind that you're going to try and solve, then none of this matters. And that's actually one of the biggest problems that I see. I walk into a customer or a partner, and we sit down, and they say, I have all this data, give me AI, I want to go do something with AI. I want AI. Okay, what do you want to do? So I think the biggest thing is really defining the problem that you're trying to solve. So I think the first thing we talk about is data. So we talk about data annotation. I think one of the biggest things that we're seeing again is this kind of sensorial, these different modalities of data that we couldn't address before because we just didn't have the algorithms, we didn't have the compute, the knowledge. And now we're able to address, for example, video. We're able to address images, unstructured text, audio information. There are companies out there like Anodot, another one of our partners, that strictly focuses on time series and detecting anomalies. So preventative maintenance. I have all these sensors. I want to be able to detect when a $100 million aircraft engine is going to fail. There's a lot of time series data that's coming at me. I want to be able to train that into an algorithm, figure out when that's going to fail ahead of time so I can prevent that, and maybe decommission that plane before it actually fails, and save a lot of customer angst and cost probably as well. Data prep. So we have a number of partners also on, not only in data annotation, but also in data prep. But a lot of the data that's out there is nasty, dirty. There's misaligned data. There's NANs. There's duplicated data. It's the dirty job of the data scientist to really spend most of his time or her time cleaning up data and prepping it. Everyone likes to talk about the model, like am I going to do a cluster, am I going to do a classification, am I doing a regression problem, what type of problem am I trying to solve? They don't focus on the data. The data is actually the key, so prepping that data. Of course, you want to figure out what are you trying to solve? Am I trying to cluster these? Am I trying to do something, maybe I have a number of articles and I want to cluster them so that I can tailor them to someone's likes or dislikes. And then of course, what kind of algorithm am I training? So, everyone's very excited about neural networks today, these connectionists as they call themselves, but maybe I don't have all of the data that I need. Maybe I only have a little bit of data. There are a number of other algorithms that you can use. Things like SVMs, for example, support vector machines are still used, or logistic regression is actually, I think, still one of the most popular algorithms for click-through rate prediction. That's a very shallow algorithm. So really it's choosing the different types of algorithms you're going to use, or even ensembling them, of course. I'll talk about that. And then model evaluation. So once I have a model, how do I measure success here? Am I cross-validating it? Am I looking at accuracy, bias, variance? Hyperparameter tuning is kind of a hot topic, especially in research these days. But how do I tune all of these different parameters in a deep neural network? So things like learning rates, if anyone's heard the term learning rate, things like a number of neurons, regularization, dropout, all these different things that a data scientist and ML practitioner has to tune. These are actually really hard things for us to think about when we're in high dimensional space. Like, what if I change this parameter? What happens then? So hyperparameter tuning actually becomes a very big problem. We kind of just push the problem when we talk about deep learning. We're no longer engineering features, but we have to think about all these parameters. And then lastly, deployment. So again, portability is key. So Raspberry Pi, dropping these onto different applications, ensembling them. So actually, if you look at Kaggle, if anyone's familiar with Kaggle, I think there's still today people ensemble a lot of algorithms to solve a lot of these problems. XGBoost, I think, is still the most popular algorithm on Kaggle, but ensembling actually is still very popular. So I mean, ensemble a neural network with some type of random forest or some other algorithm. Okay, so I'm going to jump back up to the high level, talk about some of applications and customer usage. So really cool logos here. So these are kind of some of the fun partners and customers that we get to work with on a daily basis, actually. So Too Simple, I'm actually doing a chalk talk tomorrow with these guys. They're an autonomous driving company focused on really large trucks, so more of the commercial trucks and transportation and shipping. So they're not like the Waymo or TRI or Argo AI or folks that are trying to solve the actual problem of getting an autonomous vehicle like an Uber is. But they're trying to solve shipping with autonomous vehicles. So they're an interesting company if you get a chance to come to that. Too Simple. Yep, these guys here. So these are all companies that are applying computer vision on AWS. Arteris, for example, for FDA-approved medical imaging. MapRealery is an interesting company. They actually have crowdsourced maps. They've mapped, I think, more than 2 million miles worldwide, from basically people driving around with their cars, with their phones, like when you're in your Uber and the guy has his dash cam or his phone pointed on the road. They can actually take that information, apply a lot of computer vision to it, and then use that to essentially map the world. It's actually really cool. So recommender systems or recommendation engines, I think these are pretty self-explanatory, whether you're talking about finding the right travel or shopping, Instacart, of course. I think we all use Yelp, or at least I do still. Natural language, so this is interesting. This is where things get really diverse. So whether it's Washington Post, for example, now any article you go to takes our Amazon Polly, and it actually does all the text-to-speech for you. So instead of having to read the article, you can actually just automatically listen to the text-to-speech version through Polly. I think SCDM out of Germany. They basically are applying natural language to financial information. So they're trying to extract insight out of all the financial, all those annual reports and quarterly reports. So they're trying to extract information out of those types of documents. So lots of NLP. Pattern recognition and optimization. I talked briefly about 2 cents. SIGOPS is another partner of ours. Again, once you have a model, I think anyone can train a model in a Jupyter notebook using, say, TensorFlow, but I think getting it to the point where it's optimal, getting to its, to its maximum accuracy, training it efficiently from a cost perspective, this is where hyperparameter solutions like SIGOPS come in. So really impressive company. Cool. I'm going to switch over to Jose here. He's going to talk about how to partner with AWS, specifically on machine learning. So take it, Jose.
Thank you. Thank you, Joe. So Joe and I were yesterday at an event, and there was something that our VP of Amazon AI said, Swami, that really resonated with me. And I really like that sentence. He said that we are, with machine learning, at a stage pretty similar to where we were at with databases in the 1990s. So beyond the business opportunity, which of course there is, beyond the hype and everything, we're still at a stage where we can build a lot of cool things. And in the near future, there will be a lot more even logos up there, a lot of new different use cases, and we want our partners to help us build those things. So we see 3 different ways that an AWS partner can help to deliver ML solutions to the market. Number 1 is obviously using our services, integrating with our services to deliver solutions out to the market. So we have a bunch of ML services or AI ML services, a bunch more coming in the following days, of course. So working with our joint customers to deliver a solution using our services is one of the ways, of course, to integrate for our partners. Number 2 is leveraging the AWS Partner Network. So that's the team where Joe and I belong. And mostly what we do at APN, it's co-selling. So whether you're a consulting partner and you have a customer that needs an ML solution, you can leverage APN to get help, like for instance with MDFs, with credits to run a POC, or you can leverage an AWS Solutions Architect to be able to help you have that project launch successfully for your customer. And lastly, you can monetize through the AWS Marketplace. So I don't know if you're familiar with Marketplace, but Marketplace is it's our marketplace for third parties to be able to sell their software on the AWS platform, and our customers are invoiced on our paper. So it's really good for some customers who want to procure through AWS, and you can source all the solutions through AWS on the marketplace. So one of the things that Joe mentioned briefly is the AWS Competency Program. So the AWS Competency Program is actually our highest tiered program that we have for partners, both consulting and technology partners. And this is important because there's a partner journey from where partners start as registered, then they move to standard, then to advanced, and then eventually they can go for one of these competencies. But once you're a competency partner, it means that you are a trusted partner because we've vetted your software in the case of technology partners, or we've vetted your practice in the case of a consulting partner, and we help connect these partners, I mean you guys, with our customers, because we know that you have proven customer success with us, and we know we make sure that in the future, for future workloads, you're going to have it. So the competency actually has several benefits. Well, you see there the bullet points, but basically what it is a way of, for us, sending out there to the market a message that this is the short list of partners that we work with for specific use cases, because these ones are the best for this use case. So once you're a competency partner, you get access to specific benefits, like I mentioned before, with MDFs, or even we can derive leads to you when we got inbound opportunities. Like there's a lot of inbound opportunities that come from our field. They reach out to the partner team. They ask us, who is the best partner for anomaly detection? And we will always say, okay, our go-to partners are the competency partners. And our competencies actually, we have different categories. So we have industry verticals, which of course, that's healthcare, life science, FinServ, et cetera. So that's the kind of competency that you can achieve if you're specialized in a specific vertical, both as a consulting partner or if you're a technology partner and you have a solution or a piece of your software that addresses that specific vertical, you can get one of these competencies. For business applications, they're specific to SAP, Microsoft, and Oracle. And we also have the solutions areas. So this is more horizontals for partners who are specialized in IoT, storage, DevOps, big data, etc. So as we mentioned before, this morning, I don't know if you guys were present at Terry Weiss's keynote, our VP of Alliances, but we launched a new competency. It's called the machine learning competency. Going back to the previous slide, it's going to be one of these solutions. So we went through a process with our partners to actually handpick the ones that had a unique value proposition that we knew our customers would leverage. Because they were going to be able to solve their data challenges, to enable these machine learning workloads, and actually to enhance sometimes applications with machine intelligence or machine learning. So we divided this technology category in the machine learning competency in 3 different layers. I'll go over those later. So for consulting partners, because we launched this for technology partners, for consulting partners, we're going to do this in 2018. And again, we're going to vet specific partners that have a practice with AI/ML on AWS. We're going to ask for customer references. If you work with us, you know that we're all about the customer, so we're always going to look for customer references and specific, especially public references. Those, of course, are our favorites. So if you're a consulting partner, you're interested in achieving the ML competency, well, you can reach out to me, or you can see the APN alcove that's going to be, it's going to be at the Venetian starting tomorrow, so you can ask about this program. But we're going to open this in 2018 for competency partners. And I myself come from a consulting partner. So last year I was in Spain working for Viva, a consulting partner, and we went through the process to become a big data competency partner. And I can tell you it's a very thorough process, and we really make sure that our partners have expertise in this workload. So we're going to do the same for machine learning next year. So going back to the categories that I described before, specifically for technology partners that we've been working with for this launch. So at the very bottom, we have the data services. Going back to what Joe mentioned about the dirty work, and I think there's a statistic that says that 80% of the time of a data scientist is spent or wasted actually prepping the data to make sure the data looks good and works well for a machine learning workload. So these are the partners that allow our customers to prepare their data in the best way possible. In the second layer, these are platforms that they range from platforms who are able to, even with a drag and drop kind of tool, to be able to do a machine learning workload end to end, even for people who are not data science practitioners, to platforms that enable collaboration, versioning, that have enterprise features and things like that. And in the very top, we have the API solutions. So these are end solutions. So actually, these companies have done, or they do the machine learning themselves, and they offer our customers an end solution for different use cases like NLP, NLG, anomaly detection. We've touched base on a lot of this before, computer vision, et cetera. So if you were in Terry's keynote this morning, or anyway, if you weren't able to see all this through all these logos, I'm going to just go through them again. So in the bottom layer for the data services, so we have this data annotation, wrangling, and procurement. So Trifacta Paxata, very well known for data wrangling, super easy to manipulate data. It's not an ETL tool, so you're able, as a business user, to prepare your data for a data science workload. Alteryx, same thing. Crowdflower, Joe mentioned it, data annotation to get your data right. In the platform space, I think I mentioned a couple of these guys. They range from end-to-end platforms that enable a machine learning workload to solutions that are specific for reinforcement learning, like Bonsai, Databricks. It's a full platform that saves a lot of time if you're using Spark as your main machine learning tool, et cetera. And then on the top, all these end use cases that range from computer vision, NLP, NLG, hyperparameter optimization, and some specific use cases like anomaly detection or conversational. Most of these partners are US-based. There are a couple EMEA-based. Anadot is based in Israel. Dataiku is based in France. So we're happy to work with partners from all geos, APAC included, EMEA, of course, LATAM. So don't be shy, and if you're a technology partner and you have a solution that you think is worth being part of this competency, we will help you get there. Besides what we do at APN and what I just mentioned about the competency launch, we have the marketplace. So all these solutions are right now, all the logos that you see there are right now available on Marketplace, so you can procure through Marketplace all of these solutions right now, and they're either available as an AMI that you can deploy on your account, or they're a SaaS solution that you can just connect to, and they'll do the metering and the billing for you. So all this is available. If you see how this is categorized, it's kind of analogous to what we did with APN. So we have the data solutions, we have the machine learning and data science, which most of them are platforms, and we have intelligent solutions, which are end solutions. So with that, I'm going to hand it back over to Joe for takeaways and call to action. I'll stay here for Q&A.
Sounds good. Thank you. Okay, so just a quick wrap up here. I think we've pretty much established that ML is becoming pervasive. I think everyone would agree. It's disrupting just about every segment that I talk to or engage with. From an AWS perspective, all of our cards aren't certainly on the table. We have a lot more to come. We're innovating, and I think we believe we have the premier end-to-end platform for production ML and AI, and I think our customers speak louder than we do. So we love to hear our customer stories. But really from a partner perspective, I think we're the perfect place and really the premier place for machine learning. And I think Jose went through this. I think from a development perspective, whether it's Amazon AI, whether it's going to market with us as a partner through APN, or really the marketplace and being able to monetize directly, you actually don't even need to leave the AWS ecosystem for any of that, which is pretty awesome. So a couple of call to actions. So you can try our services, so you can integrate those. So for example, with Recognition, you can try that. I think it's like 5,000 free API calls. So there's a free tier for just about everything we do. I think everything we do has a free tier, which is nice. You can also apply for the competency. So if you want to be one of our closest partners for ML, apply. There's the link that's live now. You can apply. I've gotten a few more applications since the launch, which is great. We're always looking for more partners, and as Jose said, we want those globally as well. Our customers are global. They're not just in North America or in California where I live. They're everywhere. Japan, EMEA, South America, everywhere. So, and then as a plug for my partner talks and frankly more talks that I have to come, we have a Facebook talk I'm co-hosting tomorrow with some of the engineers over there from the Cafe 2 team. Caltech, if you're around on Thursday still, we're doing what's called the Deep Learning Summit. And Caltech is there with Aaron Ames. He's bringing his robot, so check that out. So if anyone's familiar with the CAST lab, the Center for Autonomous Systems Technology lab, so think DARPA challenge. So he'll bring his robot, Aaron will, as well as the computer vision experts like Pietro Perona. Matroid is going to be talking about TensorFlow on Kubernetes. So Kubernetes is very big, obviously, now that we're part of cloud native. Too Simple and autonomous driving, so I'll be co-hosting that Chalk Talk as well. I'm doing a lot of talks these days, but come to that one. That will definitely be interesting. It'll be an intimate discussion and engagement with the CTO of a really, really interesting company. And then Crowdflower, we talked about on data annotation, SIGOpt and optimization, and then Bonsai, really applying machine learning using reinforcement learning, which is, everyone loves to talk about computer vision and natural language, but reinforcement learning is what I view as the next wave of things to come. So things like manufacturing, things like autonomous driving use reinforcement learning, and that's not something that everyone is actually working on. There's only a few really key experts in the world that I would say have that deep knowledge, and Bonsai certainly is one of those companies. So with that said, please fill out your surveys, and Jose and I would love to take your questions.